So now we're talking about, this is section 2-8. We're still going on, but it's going to get a little bit different because now we're going to be doing solving absolute value equations and inequalities. We're going to do a lot more of the absolute value stuff. And there's a lot of details here, but we're going to talk about it in just one simple idea. You got the absolute value of something. Let's say that it's equal to a number. Well, now this has two options. This could have been positive 5 or negative 5. It's got two options there. So you got to solve both. Now if I were to say x, the absolute value of x is equal to, I don't know, 7, this x had two options. So I'm going to think of this as x equals negative 7 or x equals positive 7. Okay, now I'm going to take it a little bit further. A little bit further. Okay, so now we got this x minus 2 and let's say that we're going to take the absolute value of that and call that equal to 7. Well, two ways could have gotten this, because if I did 9 minus 2 equals 7, that would be one way. The other way could have been if I did negative 5 minus 2, because that equals negative 7, but then it's the absolute value of that, which still equals 7. So we got these options. So how do we go about translating this kind of thing into absolute value with the inequalities and stuff? Okay, so let's see what we do. That would be like saying x minus 2, and it's like the plus or the minus of that is got to equal 7. Now this is kind of weird because you're trying to think, oh wait, isn't it like plus or minus 7 over here? And it kind of is. You know, that is what we're going for, but you wind up seeing some different versions of it. And you'll see that coming up. It's like, well wait, which way did the symbol go? Was it to the left, to the right? And this is going to be where we need the clarification when we go through that. But in general, it's all about this idea that it splits into two possibilities. Okay, so let's jump back in. Here we go. So the first one, it says x plus 3 is less than 2. Well, that gives us two options. That could have been that x plus 3, the positive version, was less than 2. But now here's where the other one comes in. It's the negative version of x plus 3 is less than 2. And so we have the positive or the negative. And how does that translate? Well, see, what's really happening then is now, let's say we multiplied both sides by negative 1 on this right one. If we multiplied both sides by negative 1, then you'd have x plus 3 because we got rid of that negative over here. And then if we transfer it over there, that's like multiplying by the negative 1. The other side becomes negative 2, but something crazy happened because when you multiply by a negative with inequalities, you flip that symbol. And then they say, wait a second here, let's just write it in the reverse order. So then they flip these sides and they would say negative 2 is less than x plus 3. So that's how we get to this point here. X plus 3 is less than 2, like normal, but it's also greater than negative 2. And this is just algebra. This is really two inequalities done at the same time. So I'm going to do both of them and then collapse them back together. We have negative 2 is less than x plus 3. And let's go ahead and solve that one. We subtract 3 from both sides. We got negative 5 is less than x. The other one is x plus 3 is less than 2. And when you subtract 3 from both sides on this one, you get x is less than negative 1. And all this is really doing is kind of abbreviating all that, because then they take these x's, they collapse them down into 1, and you wind up getting negative 5 as your bottom and negative 1 as your top. Okay, so what does this mean for us now? Okay, couple things. Let's talk about graphing. X here has to be bigger than negative 5. So we're starting at negative 5, and it's going to be bigger. And that's true. That works. And but it's smaller than -1. So we're only going up to -1, and we're going to go this way. And this is where we kind of had that overlap thing where you had two sides colliding, and boom, check it out. You have a line between them. Now notice, open and open, because this is not equal over on the left side boundary, and it is not equal over on the right side boundary. That is what causes both those open circles. Now that we've done all that work for just one problem, let's do one more in a different color. So now we have 2x plus 1 is greater than or equal to 3. Okay, so now this has this weird OR thing going on, but this is really what's happening. So we got the positive 2x plus 1 is greater than or equal to 3. But then we're going to have the negative 2x plus 1 is greater than or equal to 3. Now remember, this one on the right is where a lot of different weird things are happening. With the negative, because we're going to multiply both sides by a negative, then that gives me 2x plus 1 is less than or equal to 3, but negative. And then they say, oh wait, let's, I don't know, let's see how we can figure that out. Oh, look, that looks like this one right here. 2x plus 1 is less than or equal to negative 3. And then the other one was our 2x plus 1 is greater than or equal to 3. So all we're doing is we're taking the inside of whatever this thing is, taking it out and saying the plus or minus, then we take the symbol and we do both versions of it. So whatever the symbol is comes out, then we got a number over here. Yeah, okay, that seems like it's getting complex. Let's just work our way through it. So we subtract 1 from both sides and we would get 2, and then 2x is greater than or equal to 2, or x is greater than or equal to 1. No big deal. We subtract 1, subtract 1. 2x is less than or equal to negative 4, divided by 2 on each side, and you get x is less than or equal to negative 2. So let's see what happens. So we got equal, which means those are both closed circles. So at 1, I have a closed circle. At negative 2, I have a closed circle. And now, okay, what's happening with the x? Let's take this one on the right. It says the x's are smaller than the negative 2. So here's my negative 2, and the x's are smaller. So they're going that way. And over here, this one says x's are bigger than 1. So boom, shakalaka. There you go. That's it. It is that easy. That easy. I think that's it for this one. Let's just double check, peek ahead just a little bit. Yeah, that's just it right there. So we're going to get into the practice A into the next video. This one was nice, short, and sweet. Now it's about practicing these skills. So stop in here if you need to watch it again on YouTube. Talk to you later.